Well, hello everyone. So as Andrea mentioned, my name is Anton Zykov. So I work as an AI/ML specialist here at AWS. What that basically means is we help startup customers, I work specifically with startups, with any and all of their AI/ML solutions, training, inference, etc. This is actually going to be a joint presentation, myself and my partner Andy Kane. You can think of us as kind of a duo. We do most of our work very closely together. Andy is more on the technical side, and I am more on the business use case ideation side. And today, what we wanted to talk to you about was SLMs, just kind of in general SLMs, and specifically for agentic workflows. So let's dive in. So just a very brief agenda. We want to cover why we're thinking about SLMs, give a little bit of a brief brief past of what's been going on in the AI landscape, model sizes, things like this. Then we'll dive into the what, and here it's kind of the best practices that we've seen around the market, maybe some of our own recommendations as well. And then I'll hand it over to Andy, who will present a bunch of things, but mainly how to get started, as well as some benchmarks that we found. So why small agent models? Why am I standing up here and talking about smaller models when it seems like the world has only been talking about models getting larger and larger? Right? So you can definitely see a trajectory over time, right? Especially in the last 3 years, models have been getting larger, right? And with that, models have been getting more expensive to run, more expensive to run inference on them as well. And I will give to you that it does seem like the climb has subsided a bit and we've sort of flatlined. But the fact remains that the biggest models in the market are the ones that are talked about today. And they are still the most expensive to run on, let's say, a per token basis. And although we've heard, especially 2 days ago, I think, from Jensen Huang at his keynote, that they're making GPUs specifically for trillion parameter models now. What we're seeing is that these models have kind of flatlined in terms of how good they are as well, right? So this is, on the left, you've got the MMLU benchmark, basically just a general intelligence benchmark for, benchmarking LLMs, right? So what we're seeing is they're not actually getting any better, so to speak, right? A quick show of hands. Has anyone here heard of the agent company experiment running out of Carnegie Mellon? Yeah, one, a few, yeah. Okay, so really cool experiment and paper that they wrote. So what they've basically done is they've created a fake company using only agents. So everything is an agent within this company. And they've broken the company down into a few departments. Right, so you've got your HR people, you've got kind of your engineers, there's a product management team, finance team, and they assigned specific agentic tasks to all of these different teams. So there's a total of 175 agentic tasks, I believe. And they've also come up with an evaluation mechanism. Right. So how do you determine that an agent has successfully completed a task? I won't dive too much into that, but if you're interested, you can read their paper. And so the point is, what they do then, they have this set of 175 tasks, and then they benchmark the state-of-the-art LLMs in the market, out of the box, not fine-tuned or anything, on how well they can complete these tasks. And what they found is pretty shocking, that the best models out there, and granted this is a bit dated, maybe about a month old now, but the best models out there are only succeeding at around a 33% rate on agentic tasks. So, I mean, you can have your own takeaways from this, but my takeaway is that, frankly, out of the box, LLMs are not very good at agentic tasks. So, not to keep bashing LLMs, so to speak, but there was also a report from Gartner in June of this year, saying that they predict over 40% of agentic AI projects will be canceled by the end of 2 years from now. And the report actually goes on to say most agentic AI projects right now are early stage experiments or proof of concepts, and they're mostly driven by hype and often misapplied. And then they further go on to say that this can blind the organizations to the real cost. So the main driver here is cost. It is too expensive, and it is being applied to the wrong use case at the end of the day. Right? So what Andy and I have sort of been realizing in the market is that this report was correct, and a lot of the time people are just building Gen AI agents, honestly, for the sake of building agents. And I really like this analogy here. Funny enough, an LLM helped me come up with it. But you probably wouldn't expect your HR rep to write code, so why would you expect one model to do everything? But that is what we're seeing. We're seeing one model being applied to every single task that you can imagine. Right? So just a very quick recap of my bashing of LLMs. They're too large and too expensive. Out of the box, they're not actually too good at doing what they're meant to do in this case. I didn't mention, but security could also be a concern with this. So if you're familiar with the OWASP Foundation, it's an open source foundation tracking, or project, I guess, tracking any vulnerabilities or any risks that come up in software. In the last few years, they really turned their attention to LLMs. Definitely worth a read if you're interested. But the bottom line is that it's too expensive, we're not really doing it right, and it's just not performing well. Right? So where does that leave us, and what have we been seeing in terms of our savior, small language models? So we do think that SLMs can offer that performance cost sweet spot that people are missing right now. And I won't cover a bunch of the stuff on the slide, but I do want to point your attention to the two robots over there on the right. Right? So you have your large LLM, you have the small language model next to it. And the main thing I want to point out is that actually the small language model in this case, it's not just the arm of the big robot, or it's not just the head of the big robot, right? It is the entire robot as a whole, just smaller. So naturally, it's going to be better or worse at some tasks, but it is still incredibly capable, especially if you train it to do one specific task. Right? And just to slide this in very quickly, I alluded to this earlier, but that exponential growth has kind of stopped. And we are seeing kind of since, I would say, 2023, many, many more of these small models being released. So yes, they generally do come with their larger counterparts. So you'll have the large Gemini model and then maybe one or two small models that spawn off of it. But as a whole, you know, they've stopped, the industry has stopped trying to build bigger and bigger and has actually started, I think, honing in on what makes the model work better. So what Andy and I have seen in the market in terms of like, well, what is a small language model, right? We would say it's anything at the moment, probably smaller than 30 billion, but that's already up for debate. Could go up to 50, but you know, it depends. So just like it says, you know, the 1 billion models for very simple tasks, the 3 billion, this is when you start getting into sort of more specific domains or industries. And then the 7 billion ones are actually completely capable of a lot of the complex tasks that you expect an LLM to do, as long as they're hyper-focused on doing those tasks. And I didn't mention yet quantization, but we do feel very heavily, strongly, positively about quantization. And it is effectively a way to make a model a lot smaller, right? And I think the main takeaway is that you can make a model significantly smaller. I believe it's 2x every time you go down, right? But you're only losing a bit of accuracy. So even when you're going down to 4-bit quantization, you're only losing maybe 4 to 6% of accuracy, which I think is very impressive. So the main takeaway of everything I've said today, basically, is that I think we need to stop expecting an LLM to do everything for us. And instead, I think it makes a lot of sense to have multiple agents working orchestrated together to achieve, let's say, a list of different tasks that they have, but use those separate SLMs and actually target them to specific tasks, right? It'll be hundreds, if not thousands of times cheaper, and you may actually get a better result. And this is where I'll hand it over to you got your own, to Andy, who's actually going to walk through, first of all, some implementations that he's been doing himself, some early stage, and then actually some other research that we found in the market that actually proves this point, that you can be smaller and better. So Andy.
Wonderful. So let's jump straight into the data. So Anton's mentioned the greatness of small models, and what I want to do is prove that with some science, hopefully. So I'm going to start with quantization because quantization is really easy to do. If you're a fan of All-Llama and like to run models locally, it's all done out of the box for you. You just pull the right quantized model. What you see on that slide is the quantization of a family of models starting from, I'm going to read my own slide, 65 billion down to 30 billion, 15-ish billion, 7 billion, 1 billion. And what you see on each of those lines is the square at the end is the full-size 16-bit model. So that's your full-size, full-fat LLM. And quantized all the way down to 2-bit. Now, if we were having this conversation a year ago, we probably wouldn't be talking about 2-bit. Well, it's 2 years ago. It just wasn't very good. We tend to suggest to stop at 4-bit quantization. But what you actually see from the benchmarks is even at 2-bit quantization, so that is halved once, halved twice, halved almost 3 times in size. So you're going from 16 bits per parameter to 2 bits per parameter. The larger model is always better than the smaller model. So what you're actually looking for here is, this is perplexity up the side. Perplexity is essentially how confused the model is about what the next token is going to be. Higher is worse. You want that number as low as you possibly can. What you see is that little purple line at the bottom is never above the bluish line. It is always better. It's always best to start with quantization, and we can prove that. You can't do things like this with closed source large models because they don't allow you access to that model to do it. You need to use an SLM, you need to use an open source model to allow you to do this kind of work. The next benchmark is fine-tuning itself. So what you have here is a benchmark across 37 different tasks, from coding to classic natural language processing, to question and answer. So 37 different benchmarks across a lot of models. What you have is some of the best down at the bottom. So you have ChatGPT 3.5 Turbo. And what you see is the dark line is essentially your unfine-tuned model. And the nice light blue shows what you can achieve by fine-tuning those smaller models. And what you'll see is you can, on narrow domains, improve upon state-of-the-art models with small SLMs fine-tuned for that task, specifically for that task. So that proves we can do it. How do you do it? So SageMaker offers 2 options for doing this. We have fully managed training jobs within the SageMaker AI product, which allows you to provide your code, kick off a job on an instance or multiple instances. It runs, outputs your model, outputs your fine-tuned model in S3, and then you can pick that model artifact up and go and deploy it wherever you wish. Inference endpoints into an EKS container if that's more your thing. And on the other side, we have Amazon SageMaker Hyperpod, which is a resilient self-orchestration infrastructure platform for model creation, model fine-tuning. So this is essentially a managed HPC cluster, for lack of a better term. And it deals with managing all that cluster for you, so you can go and submit your training jobs, have them run on that cluster, and again, produce that model, which you can then go and deploy anywhere you need to. So fully managed training jobs, there is essentially many ways to train this model. It is purpose-built infrastructure. If one of the nodes goes down in training, it will automatically restart that node from your last checkpoint. Essentially, you just don't have to worry about it, which is the main takeaway. Start your job, let it run, get what you need. Hyperpod is a bit more involved from both an engineering and an operational point of view. This is really for those large tasks. If you were going to go and train the next trillion parameter model, this is why you'd go and do it. It does have some serious benefits if you are fine-tuning. Essentially, it gives you much more access to the underlying OS, so you can go and make those tweaks if you're doing something new and unique. And if you're doing reinforcement learning, which is one of the better ways to do fine-tuning, especially for agentic workflows, Hyperpod is definitely your best bet because it makes that communication between your training task and your reinforcement cluster, be the IDEs where you're running some code generation, significantly easier to achieve. The reason I bring these up is because they both bring things to the table that makes training your model really easy to begin with. With Hyperpod, we produce a bunch of recipes. So if you want to go and do PPO, DPO, GRPO, reinforcement learning, there are recipes for those which you can go and pick up from our awesome distributed training repo on GitHub and just go and deploy and just run with and just start with today. On the other side, we have within training jobs, we have something else in SageMaker. If you haven't come across it before, SageMaker Jumpstart. SageMaker Jumpstart gives you access to a 250 plus publicly available foundation models. A lot of the Hugging Face models, a lot of the meta models are available on there. Again, the reason I bring this up is because if you click on one of those meta models, there is a small button at the top of the screen that says train. Fine-tuning an SLM from these providers is as simple as going into the console, for anyone that likes ClickOps, clicking the train button, providing an S3 bucket that has your data in, and pressing go. It is just that simple. What that actually looks like is this. This is what's actually doing the heavy lifting, at least in the Jumpstart case. So Jumpstart does SFT, so it does parameter fine-tuning, instruction fine-tuning. It does not do the reinforcement learning. So essentially what you're providing is a prompt completion pair. So this is your input to your LLM, this is your expected answer, and this is training that model to get closer to that response based on that user input. There isn't too much to it. The input is a JSON lines, which includes a question, a context, and an answer in a JSON dictionary. That's it. You point it to your data, it kicks off, it runs, it suggests the correct instance size based on the size of the model that you're trying to train. It gives you some really sane defaults for hyperparameters for that model. If you want to change anything, you absolutely can. If you don't want to change anything, press the go button. That is it. That's how you get started doing this. That is the easy part. Like most things, pressing go is easy. The data is difficult, and there's no hiding the fact that the data is difficult. Creating those pairs, difficult. Getting clean data, difficult. If you're doing this for an agentic system, you're going to want those reasoning traces. There's no way of getting around this. To get those reasoning traces, you need to run that LLM at scale to get those reasoning traces, to then go and fine-tune this smaller model. There are ways around that. You can create synthetic data, which is really a form of distillation where you use a really big model to generate this upfront, to train the smaller model, to then run in production, which is where you start seeing those cost savings. The other option is, about a week ago, there was a release called Agent Lightning, which is essentially a Python tool which you connect into your inference scripts, and it collects those traces in real time while your agent is running, and it does whatever it needs to do. It can do prompt fine-tuning for you, and it can do reinforcement learning of that model. Essentially, it's online collection of data and real-time, near real-time changes to that agentic system as a whole, either as an individual agent or as a set of agents, to give you an overall improved agentic flow. I'm not going to go into any real detail on how to get this data, because that is very unique to whatever it is you're doing. What that data is going to look like is going to be very, very unique to what you are doing, what you're trying to do. This is more of a, this is how you can do it. From an infrastructure point of view, from an actual training point of view, it is very, very easy to get started once you have that data. If you would like to have a conversation about how to get that data, find me outside afterwards. And that is really it. This is really just a, this is how you improve it. This is how you make them smaller, cheaper, faster, and, at least for me, better for the environment. The environmental footprint of an SLM is significantly improved versus the LLMs. And I think everybody could agree that having water and trees is a good thing. Excellent. Cool. Anton, do you want to come back? I'm going to take a handful of questions.